For somebody as young as Soen, Ted Nugent actually sang music before he was a hunter and gave away free deer meat.
Sweaty Teddy.
I have to search.
Oh, that's funny. He was, what was his moniker about Detroit? He was
the Motor City Madman.
There you go. Yeah, thank you.
And Ferocious Theodosius.
Evening, Sam. Are you feeling better?
Oh, yeah. In kind of inventory mode. But today it's much better.
Well, Al, Jeff didn't take your introduction.
You didn't like that?
He's getting his slides ready.
Yeah.
His 3D drawings. I got to play around with the simulator this weekend. Add some ultrasonic sensors to it. And then you notice on the last run through, it hits the wall. That's what we need to prevent.
It's easier to do that in software than it is in hardware.
I saw the video. I haven't had a chance to download it on my computer yet. Yeah.
There's an open pull request with it, so it's not put into the master yet.
But it's on a branch probably, so I'll be able to download the branch and try it.
Just on a side note, just came across this package. I think it's just pretty new. It's called ROS Show. It shows the topics that this is in active development at this point, but it shows the topic directly into your terminal. So that's something of interest.
Thanks, Sam. That is an interesting package. Super lightweight. You can just run that in the terminal. You don't have to open up anything. The other thing I thought was fascinating is that it seems to show the GPS points.
Yes, I haven't used it, but I just came across today, so I just wanted to share.
Evening, Colin. Colin, what's new down in your world? You're on mute. You're on mute. Oh, it shows you on mute. I don't know why. Okay.
Yeah, no, it's okay. Yeah, nothing much is happening. Snowed under with assignments and stuff like that, but I'm coping.
Great.
Matt, did you want me, excuse me, did you want me to share the video of the parts I had fabricated?
Sure. I think it looks awesome.
Let me see if I can get share turned on here. So I had sent, I don't have the welding skills that some of you guys do, so I had sent my lawn tractor to a welder machine shop guy, and he put 4 or 5 parts together, and I took just a short video to walk through the parts. See how the video comes across here. Share.
It's nice that you guys have your gas tank down below.
I don't know how much of the sound came through on that. Matt, did any of the sound come through?
I didn't hear any.
No sound at all?
Unless it was very low.
Yeah, sorry. I'm not a big loud talker.
Starting to look like a robot. Man, that's a lot of work done.
Yeah, so I didn't count the parts. So there's 1, 2, let's see, 3, 4, 5, 6, 6 or 7 parts that he fabricated there. So he charged me for 20 hours of work. He and a buddy, he said, worked on it. I thought what was really cool, I mean, he's got access to a lathe and knows how to use it and all that. This is a solid rod that goes between the servo and the transmission, which is back here. And he sort of just cut it to size and put threads on the inside. And so I wasn't smart enough to give him the servo in neutral position. So that'll take some. My suspicion is that's probably, well, you'd have to tell me, when the servo's at 0, is that full reverse? Is that the expectation, is full reverse?
I think it does go to like one side, but maybe that's not a, oh, yeah, if it's full, I think it's full one way. You're right. So if you're in the middle on your transmission, you'll need to shorten that or adjust that length.
Yeah, so I wasn't smart enough to get him the servo with it being in the middle position. So anyway, it's a good start.
Yeah, it's impressive.
Jeff, I can see your lips moving, but I don't hear anything, man. No audio, brother.
I'm out of here. Relog in.
Heck with you guys. So it would have taken me forever to do that. So now we have a model to build upon or change around, make better. Speak, Brother Jeff.
You're gonna have to use sign language, Jeff.
It's broken.
Hey, now we can hear you.
Oh, you just a little bit. We heard a little bit come through.
Hello, hello.
Just a little bit.
Well,
It sounds like you're on, volume number 2.
okay, well, it's broken then, so I'll just go away.
You're getting closer. Well, does it feel good to have all those mounted up now?
Oh, it's good, and then it's still frustrating because anyway, I've got to have him come back and tack weld the steering U-joint to the steering shaft. He was nervous about doing anything with that because he didn't exactly know how the motor worked. He's like, I was afraid I was going to make something that couldn't be redone. So anyway, at least I have it back, and now I can
Just-
mount the angle sensor, which is the next step, is to get the angle sensor potentiometer mounted.
Just in summary, your front wheels, are they sitting below some motors that control them?
Colin, ask your question again in a different way. I didn't understand.
Your front wheels, how are they connected to the transmission and steering wheel rather to the steering wheel? How are they controlled by the steering wheel?
Yeah, so you can see my screen, right?
I can see your screen here.
So these are that's where the annotation thing is. Draw. Front wheels are here. Here's the control rod. This is the control rod for the front wheels, right?
Right.
This motor has a shaft that goes down here, turns this gear. This gear turns this, I'll call it half moon gear, which then makes this rod either shorter or longer and delivers that angle to the front tires.
Okay. So how do you measure the position of the tires? Or at what point are you connected to measuring which way the tires is turning to?
Yeah, that's a darn good question. I don't at the moment. I'm looking for my potentiometer. I don't have it here handy. There's two screw holes here, and the potentiometer is going to get mounted here and be driven off of that gear. So it's not done is the answer, Colin. I don't, but that's where the potentiometer would be installed, which is basically the same configuration as Matt has. I'll probably have a little bit of a different potentiometer holder installed here, but it would be basically at the same place.
So there's still some discussion whether, so I have mine on the outside of that, the spur gear that the motor is connected to, and there's a little bit of play. Jeff has we've talked about it before a few times, but may need to measure how much that moon gear turns. There's a little bit of slop in between those two gears.
Okay.
Yeah, I don't know if I have a better view of that gear from the other. Yeah, that's a little bit of a better view. So again, that's the gear to have another gear mounted against to drive the angle sensor. Not in this picture. Work in progress.
Good work in progress.
Still behind Matt, though. We're all still behind Matt.
You're getting closer. I'm getting nervous. Got to speed it up. I was trying to find that picture. There's a picture of it in the lawn tractor channel. If you want to take a look at that gear. Looks good, Al. Great progress.
When in doubt, hire a welder.
I thought you were going to say, when in doubt, weld it.
Well, welding and concrete, they sort of remind me of like permanency, right? It's like make things that they're going to be around a while. Jeff is the Renaissance man. Jeff does it all. He welds. He didn't have to hire any of that stuff out. He welds it himself.
So, did you get a chance to work on the safety system?
Haven't yet. Been doing some other stuff, but I've been thinking about it. So haven't just implemented it, so I don't have anything to show. But you'll see some of those commits soon, or hopefully sooner. But yeah, I just pushed some commits to the website, so that should be up. It would be nice to show everyone how to commit changes to the website if they wish to, so that we can add to our knowledge base and not forget stuff. Sometimes it gets harder to search things on Slack. I've been reading a lot of papers on path planning, So I just posted those on the website so that they can stay there. I still have to look. I usually what I do is if I find something interesting, I send it to myself on Slack. So I have like a big list of chat messages to go through to find out what you know the good stuff that I can post on the website. But I've started with a few that I know for sure have changed how people think about path planning and stuff. So yeah, that's all. That's what I've been reading about lately, and working on work stuff. So
Thanks for posting those links. It's useful. It's easier if it's listed on like one page on the website instead of searching, like you said. And path planning is a big topic. It's amazing how many articles and studies have been done. It's a huge, huge area.
yeah, from what I've learned so far is it's been an influx. So so Dr. Harvey Choset from CMU has done significant amount of work on this topic. He was the person to introduce an algorithm called the boustrophedon decomposition algorithm. And the word boustrophedon means the way of the ox, which is the animal that was used to make row passes in the olden days. It's all about it's about making back and forth passes. There have been before he published this paper, there were some reservations on how to approach complete coverage, because some of the algorithms were not, if they were efficient, they were not complete, so they wouldn't complete the path. So what he proposed, and he and his partner talks about cellular decomposition, which is taking a piece of or taking a polygon, which is how we represent a field, taking a polygon and decomposing it into smaller cells. And this was done previously. It was done by trapezoidal decomposition, which is you make slices, and I don't know if I'm making sense, but you slice the polygon at the vertices. So there's a lot of smaller cells, and then you pass through each of the cells. What Dr. Choset came up with was you don't make as many cells. So you minimize the cells while still decomposing the polygon into smaller spaces, and then traversing each of those smaller spaces individually. And you can take a look at this paper. It's pretty interesting. So and most of the work that has been done since then has all been using some sort of decomposition. So it comes down to two different ways. If you use a trapezoidal decomposition, you decompose the polygon into very small parts, but then you merge again. So it's called slice and merge. And then the other way is to use the boustrophedon, and then I think it's more relevant to go and read about these, because we want to do row passes, and because this particular area of research also deals with other complete coverage problems, such as vacuuming a room. So, and that comes into indoors, and there are different ways how things change from indoors to outdoors. But one of the things that matter is the way you fill out an area. So the most efficient way to do it, and this has been proven, or this has been seen by pursuing the problem with different approaches. So you go with an algorithmic approach, or you put a neural network at work, or you put genetic algorithms at work. All of these, if you try to find the most efficient way, it all boils down to back and forth motions. So it has been proven, which is pretty cool. So yeah, lots of good stuff. It's quite a bit of heavy reading, but it's interesting and it's fun just to think about how old this problem is, and how so many people have been trying to solve it. So yeah,
I like the connection back to the ox and the fact that they were doing it the most efficient way, and they probably weren't calculating their passes on algorithms,
yeah,
but they figured it out. This is the fastest way to get this done.
yeah. I think this is the fastest computer on earth still. So
So, just for my own understanding on the path planning, so the problem you're trying to solve is to understand how to get maximum coverage for a given area, or is it more like how to get maximum coverage with speed, or what is the higher level problem statement with constraints?
sure. And this is not the problem I'm trying to solve. I'm trying to understand how these people have published about different approaches. But from
It's
what I
fascinating.
yeah, from what I understand, it's the problem statement is something like this: given a polygon with holes, so not all fields are uh, rectilinear, which is they're not complete boxes. There might be some spots that there might be something in between, or a shed, or a windmill, or just a scarecrow. So you want to be able to map those things, and this problem particularly about the path planning is and I'm looking at offline stuff. There's different ways to approach online as well, but I'm talking about offline right now, and some of these statements might be common between these two approaches, online and offline. So the problem is, given a polygon that may or may not be with holes, but worst case scenario, there's lots of holes in it. Given a polygon, what is the best way to completely fill the area, given that what's your, and I'll use a Ross term here, what's your base footprint. So you know what your base footprint is, and you're trying to cover an area completely. And what's the most efficient way to do that? And how they do it is by decomposing it into cells and then running an A star. And I missed this A star part. So then you figure out all total number of cells you have, and then you find out what's the best order to fill those, or to fill those cells in one by one.
Got it. Cool.
It's pretty neat. I'd recommend reading. I'll keep posting more links on to the website, and we'll all be on the same page soon.
Yeah. Sounds very interesting.
Thanks, Owen. Kalyan, how's the perception group?
So yeah, so we made some goals for our group. We made some projects on GitHub. And Chinmay and we are teaming up now to see if we can push it a little bit faster and farther. So for anybody who's interested in perception problems, we have created a project on GitHub. Let me share. So we created a project here. As a project, the idea would be we would start with a couple of simple ones. The first one was the weed detection, and we broke that up into smaller blocks which we can achieve. But the end goal of this project is to come up with a neural network on. We are hoping that ideally we would use a nano edge at the end of the day, and then it would detect the weeds as the robot is in motion. And the other people who might be working on weed spray detection can take the locations of the weeds from from the perception block, and then spray the chemicals on the weed to kill them. So I'm thinking we'll put a goal of trying to get this done in next 2 or 3 months, and we'll keep everybody posted about our progress on this.
It's good. It's a fun project. It's a little difficult.
So I got this video size like about 3-4 gigabyte. How I cannot probably manage to upload that. How can we go about that? Like, do I need to split it up or just go downsize on the resolution or something?
That's a very good question. We were talking about it last week as like if people want to share their data sets, how do we create a repository without breaking bank on this data set? So sooner or later we would have to figure out some way to do this. Right now we're thinking maybe we could use a Google Drive. Google Drive allows up to 100 gigabytes or so. So maybe we can start there for sharing this. I mean, 4 gigabytes is not that big of a file, but as we start adding the training data sets and the real-time collection data sets, we need a location to put all these data sets at a much place. So for now, maybe we can share through Google Drive.
Okay.
Sam, there's a perception folder in the Google Drive, the Frost Agriculture Google Drive. There's a perception folder, so if you want to put your data there or create a data directory.
Okay, I'll start. I think 3 to 4 gigs. It will take like I don't know how many hours, even because mine upload is like about maybe 5 to 10 megabyte. So not more than that. So it means it will take like I don't know how many hours.
The 4 gigabytes.
Yeah.
I don't think it shouldn't take that long. It should be pretty quick nowadays to push that 4 gigabyte. But what I think when we have your data set, what would be an interesting exercise is to annotate this data. So to put like bounding boxes around the weed and non-weed location. And then what I would like to do is maybe when we do this, we would want to identify a tool chain which can allow us to do it very easily and probably benchmark how long it is taking for us to annotate the videos. There are some cool annotation software where if you upload the video and then let's say you draw a bounding box across one object, it will track through next 10 or 20 frames so that you don't have to manually go and annotate that as long as that object is there. So what I would like to do is, maybe figure out like what is the standard way to do this with your data set, and then maybe understand how much time we are spending in annotating these.
Yeah, maybe what I can do is like edit the video and then just take maybe a minute or two or something, which has some data.
Okay.
And that would be easy to annotate too, and then that'll be easy to extend it to the full length of the video probably later on.
Okay.
I think like 2-3 minute clip or 5 minutes clip would be actually a good idea probably.
That's okay. You can totally upload 4 gigabytes of data, and we will annotate only 1 or 2 seconds of it. we'll only annotate, maybe half of the video, so that's okay.
Okay. Okay, cool. Just have to figure it out, and hopefully I get some time like this weekend.
Mhm.
When you are done, when you are through, how is your system going to work? Can you explain how you are going to be dealing with weeds? Will it be mounted on a bar and spraying the weeds? How is it going to be working?
Leon, you want to take that, or you want me to? I mean, this
Go
is.
ahead. I think I missed the question, but yeah, go ahead, Sam, if you want.
Okay. So, Colin, the idea is, once we detect, the weed, and then I think that will be based on the video feed. Somehow, we also will detect that where the location is, and then that would help us actually kind of spot and spray. So we're going into that direction. This is just very high level. I'm not sure what the mechanical device or even the sprayer that we would use, but at least if we start identifying the weed at this point, it means that if we start locating it, for example, where it is exactly, if we are under the moving vehicle, let's say, for example, and we're continuously taking a video, and then, it would as soon as it detects the weed, it should spot spray. So I think that's the whole idea behind the weed detection, and then actually grow onto that idea, basically to either mechanically remove the weed or just a spot spray. But
okay,
this is
so
very high level.
So did you have yet to look for a list of all the weeds that you've come across in the field to feed first before you introduce it to learning about more weeds? For example, if I have got typically 5 kinds of weeds and I've taken pictures, download it into the system, and then as you go, you add more weeds. Or do you have to take pictures of weeds each season?
So I think it'd be depending on the your field, probably. If we can get the photos of those, or maybe even a video feed, the first thing that probably Kalyan has to do, and this is Kalyan, just correct me if I'm wrong, but you have to identify the weed portion into that video, which is what we call the annotate. So it means that into that video feed, which is coming from probably from your field, you would tell us that this is the weed versus this is not. So what we can do is we can identify into the video, and then we can train, the data, and then we can train the whole data set. It means that now if you're running the whole video feed, we'll be able to identify, as long as we see the weed, it would highlight that, okay, this is the weed. So I think once this is done, I think it's just probably the question of training the data for a specific weed. Is that true, Kalyan?
Yeah, I think so. That's a good question. So initially we might train our model to identify 1 or 2 weed data sets, but as everybody starts to identify new types of weeds and new data sets, we would have to go and retrain our model to identify additional weed sets also. So it will be like a continuous learning process for the model. So over the time, the model will grow in its capability to detect maybe tens to hundreds of weed data types, and then start locating those. So in the initial phase, maybe we might detect only 2 or 3, and as the whole team identifies more data sets, they can upload their data set and categorize, saying this is my weed data type, and here's the name of the weed, here's where it looks on the picture. It will start to learn more and more models. So does that help?
Yeah. What I've been doing on my farm is that every year I will take pictures of all the weeds that I came across. and identified by the national name as well as the international name that apply to the weeds. So I have a bunch of pictures, quite a number of them. The idea being that I need to manage the quantums down. If each year I find that I've got morning glory that is covering, say, so many plants per square meter, I need to know whether I'm succeeding every year, whether the quantities per square meters are reducing or the quantities per square meter are increasing. Basically, I want to avoid my weeds or the weeds to get to the stage where they flower and produce seed and multiply in the following year. So because of that, I've been taking pictures every year. But the trend is basically those weeds that you are used to seeing are the ones that you have. Because here in Zimbabwe, we don't have a system that you guys have where combines are hired to come and do a piece of work and then the guy goes somewhere else. That system probably will bring in weed seeds from some other farm to your farm. So you can get into a system where you can continue to have new weeds that you've never seen. But for my system, I have my two combines. Yes, my farm is split into two. The other combine will be combining in other fields, the other one from the other fields. What we have noticed is that when you take the other combine that is used in field group A to go to group B, you begin to see the weeds that were in group A now showing up in group B. But I'm taking a keen interest in how your project is coming up because it's something that is directly relevant and interesting to my weed management. Eventually, if one is able to do it using a system like that, then it cuts all the costs down because you reduce, you're not going to spray every square meter that is available. You're only going to spray and target on the weed. Is that the way it's going to go? Just targeting on the weed. When you spray, you're spraying on the weed rather than spraying on areas.
So I think so. That's exactly the idea, that you identify bulk and then you spray or you mechanically remove. So it will be not spraying the whole field, just identifying it and then spraying it.
Yeah, as Sam said, yeah, the idea would be to not spray everywhere, but only localize the spray where the weed is present, and then just kill that portion. But we have a long way to go there. First, we have to identify the weed, then we have to localize it, then we have to make sure that we have a good accuracy when we are spraying the chemical onto the weed. So lots of testing and validation needs to be done before we get there.
Okay. Interesting.
Yes, indeed.
Cool.
I was,
I'm actually glad that you guys are interested in the project. So that gives us ammunition for us to work a little bit harder and go a little bit faster. So.
Yeah.
it's needed and useful. I was working on robot localization today, and I don't know if it's a very large package and there's a lot to it. But one of the setups, this is just a little story of working in ROS for me as not a software developer, but one of the things they say to do is you need to make sure when your IMU, when your tractor is pointing east, that your IMU needs to read 0. The yaw angle is 0, right? And if it isn't, then there's this yaw offset that you need to put in, so you make sure that when your tractor is facing east, your IMU is reading 0. But I'll show you what IMU data looks like. I don't know which screen it is. Okay, so can you see, this is what IMU data looks like on the ROS topic. Can you see the screen with the output?
Mm-hmm.
Yeah.
Yes, I can.
Okay, so under orientation here, that's where it tells you which direction your robot is pointing. But from that, these are quaternion angles. It's not, it doesn't clearly, for me, I can't clearly see which direction it's pointing from these 4 angles.
Got quaternions.
Yeah, I need quaternions too, Euler. So it's like every step is learning all of these concepts, and some of them are a little complex. But the nice thing about ROS is that there's so much software built out there. You can go to GitHub and do a search, and I found someone did IMU to angles. And so if you just run this ROS node, it takes in your IMU data, and then it will, so this is this is that orientation that your IMU data sends in, but then it will publish your yaw angle. So this makes it very easy for me to see what my angle is of my robot. So even though some of the things may be complex, there's a lot of software, and people have done a ton of work out there to make it easier. So it's a part of understanding what you need, and then going to GitHub or going to the ROS wiki and finding the solution. But that was today's kind of little experiment.
Just a fun tidbit that quaternions to Euler transformation is one of the highly asked questions in robotic interview questions. Like, everybody gets asked that. If you do that, like, you are above the threshold in terms of robotics knowledge. So just let you know.
You know, and the funny thing is the documentation is not good. So for any transformations, like for example, we wanted to use, for everything else in terms of transformation, we wanted to use TF2_ROS library. But just for the transformation from Euler to quaternion and quaternion to Euler, you wanted to use the TF library. And then that's only exists there, you know, in TF, which is the old library. So in most cases, you know, they just know it's, you know, written, but then you go through some of these blogs and they will say, oh, when you do this Euler to quaternion, you wanted to use TF, and for everything else, you wanted to use TF2_ROS, you know. So that's one of the other insights where you wanted to convert from one to the other. Oh, I was looking at the result. Is that not the quaternion? W should be 1, Matt?
If you're pointing east, okay, here's the other weird thing that I don't know a lot about, and that is the coordinate frames, ROS versus other industries. We use north up, I think, and so typically you would have, for your orientation, I think it would be like, I think X is 0.707 and Z is 0.707.
Right. So then that's into the Euler, and then that's ENU frame. But you get into the quaternion, I think W should be 1.
Okay.
Yeah.
That's good to know too. Maybe that's a shortcut. So if you point your robot east, it would be nice to know what those numbers need to be, and then you can adjust your offset or add the calibration.
Oh, and plus your U offset also should take the magnetic declination into the factor, so that you have to add that too, I guess. When you offset your, like for your IMU, if it's just the 90 degrees to the north, when you do your offset, you have to also consider the magnetic declination at your place, wherever it is, and you have to add to that to get the right east, I guess.
What's the motivation to transform from quaternions to Euler angles?
Well, if somebody says that, you know, if you have your robot pointing east, your yaw should be 0 degrees. Well, where do you go to find 0? Where do you find that 0 degrees? If you have ROS topics and you have these sensors running, there's no place that gives you that degree.
Yeah. I don't know, but I'm finding some of the material that are on Coursera very useful. They've got a course called Introduction to Robotics, and another one called Control of Mobile Robots. There's a lot of mathematics involved, but it makes a lot of sense when it comes to the things that you are talking about. I'm sure by the time you get down to the ROS system, you'll be having an idea of what's actually happening even within the system. Even if the system makes it easier for you to use, you still need to understand what is behind what is happening. The maths are not easy, but once you get it right, you begin to understand. Particularly when you go through the PIDs and the stuff like that. But I think it's something that those who are interested can go and refer to. It's you can just read it for free, because the point is not to get certificates, but to get an understanding. Even if you have to do one chapter in 2 weeks, so be it. The little bit that you get adds to the other that you knew. And that's part of the stuff that I'm actually reading at the moment.
It's great. It's a good idea.
Totally agree. I mean, it's just the concepts, and I think the good part of the RS is takes the math, out of the equation. So if you know what needs to be applied, there are functions available, methods available for it. So you don't need to actually get into the detail unless you want to. But the only thing that you need to know is what you want actually out of it. And I think for the quaternion too, I think it's, Kalyan, to your question, I just wanted to add to it. I think it's some of the algorithms and the matrices calculations makes it easier with the quaternions rather than getting into the Euler. And then I think that's one of the reasons that they use internally X, Y, Z, and W.
Got it. Okay.
Evening, Alan. Glad you were able to join us and make it in.
Yeah, thank you. I don't know if you can hear me. I'm working on my sound yet.
Yes, it's a little low, but we can hear you. It's off now, or really low.
I'll work on it.
Okay. I think we could spin up another team just on localization, working with IMUs, GPSs, and wheel encoders, and doing dead reckoning and getting a final position. Putting something together so other people could download and go. We've worked on tractor localization before, but it's still, and there's a really good documentation from Lino Robot on sensor fusion. One of the best write-ups I've seen so far in putting it together. But even today on the Robot Igniter, they constructed a live class on fusing sensors and robot localization. So there's still a lot of questions, and it still takes a fair amount of work getting all of that together.
Yes, the localization data is like expensive. But I think this is really good because it allows you to let a lot of sensors use it and then give you the localization. I mean, I would wanted to take the light approach on that, but I'm not sure if there's any other packages available. The localization package, obviously, is just I think one of the widely used and the best package, I guess. So to go with that, I think there'll be a initial little bit of work just to set it up and get it right. But I think once it starts working, once we get it right, I think that's just the way to go.
Still working on it.
The other one is AMCL, but those are the two major localization packages. This one.
AMCL is used a lot in indoor robots.
Yeah, and things change a lot when you go out in the real world. But
that's a good package. That one's used widely too.
Yep.
Alan, glad you could make it. Sorry we didn't get the introduction. Maybe next week we'll get the sound working. It's great seeing everybody tonight. Is there any other topics, suggestions, points? If not, hope you guys have a great week, and we will see you in the Slack channel.
Thanks, Matt. Thanks, everyone.
Thanks, everyone.
Thank you very much. Thank you, everybody.